Negative exponents are not your friend. Does that even make sense? Negatives are not your friends. Okay. Let me just give you a gist of what I mean by that. Here's the deal. Here's a regular exponent. 3 to the second power means what? 3 times 3. It's not 6, but it is 9. We're all good with that. Well, a negative exponent looks like this. Okay? It is 3 to the negative 2 power. Okay? Now listen carefully. Here's the part where I will tell you over and over again and you won't listen. Okay? Tomorrow you'll come with the wrong answer and I'll say, well, I told you that. The exponent, this negative 2 exponent has nothing to do with your answer being negative or positive. Nothing to do with your answer being negative or positive. Just because this exponent is negative, okay, my answer is not negative. Nothing to do with it whatsoever. Now I'm going to give you the little brief summation of what the answer to this is. Okay, but in order to do that, we have to kind of think back a little bit here. Okay, let's look at this problem here. Let's use x's first. Okay, if I have x to the third power over x to the second power, and I asked you to simplify that, what would you do? What would you get? Anybody? Well, here's kind of how we did it before. X to the third power means you have x times x times x on top. X to the second power means you have x times x on the bottom. What's going to happen with those? Rockwell?
2 x's get crossed out.
Right, you're going to cross off like this x with this x, and you're left with a x to the first power, which is, you don't have to put the 1 there. So, I think we had this rule here, didn't we? That if you have, how do I get a 1 when I have a 3 and 2? You just take and subtract, right, the exponent on the bottom from the exponent on top. Well, boys and girls, ladies and gentlemen, here is where the mind warp comes in. Let me flip-flop this problem and say, what if my problem said x squared over x to the third power? If I use that same rule there on the whole subtracting thing, what is 2 minus 3? Jackson?
-1.
Right, so the answer to this is x to the negative 1. That's where a negative exponent comes from. But what is it in reality? If I were to simplify this one, just like I simplified there, I get, just like Rockwell said, cross off this one with this one, this one with this one. What do I get? I'm left with a 1 on top, because you never have the top go completely away, and an x on the bottom. Which means this, x to the negative 1 power is the same as 1 over x to the positive 1 power. There's the explanation that most of you didn't get. But you don't need to be able to get it, because the simple rule is this. The simple rule is this. And this is what you have to do. To make a negative exponent positive, I'm going to use the word simply because it's very easy. Simply move it with its base, which means the number that's in front of it, from top of the fraction to the bottom, or vice versa. I mean, what vice versa means?
So on.
No, that's que sera, sera. Vice versa means the flip-flop is true too. In other words, if it's on bottom, you move it to the top. If it's on top, you move it to the bottom, vice versa. This is the rule, and this rule, again, probably won't make an incredible amount of sense to you until we do some examples. Okay? And the first example is going to be this 3 to the negative 2 power. I'm getting tired of the red color, so let's make it blue again. Okay, 3 to the negative 2 is not something we deal with well. You need to change the exponent to positive. Well, in order to do that, okay, I'm going to make a fraction out of it. Just put a 1 under it. In order to make the exponent positive, I just take this whole thing and move it to the bottom of the fraction, which means it's going to be the same as, and I still need something on top, which is a 1. 1 over 3 to the positive 2 power. The only thing that changed signs was the exponent. When I moved the whole thing from the top to the bottom, the exponent changes sign. And you know that 3 squared is 9. So 3 to the negative 2 power is the same thing as 1/9. Okay? Don't worry, we will do a plethora of examples here. Do you know what plethora is?
A lot.
Mucho, many. Let's say I have x to the negative 5th power. Let's say I have 3 to the negative 3rd power. Let's say I have 1 over 5 to the negative 2 power. All of those have negative exponents in them that need to be changed to positive exponents. Because in math, we don't deal with negative exponents. You're really not even allowed, there's only one time you're allowed to use them, and we'll talk about that in a second here. Okay? We're not allowed even to keep them. When they say to simplify an answer, you can't have a negative answer, negative exponent there. So, how do I make this positive? Well, how do you make a negative exponent positive, Nick? It's on the top of a fraction. To make it positive, I just move it to the bottom of the fraction. So this is 1 over x to the 5th. Again, noting that just because this exponent was negative did not make my answer negative. It has nothing to do with what your answer is. How about 3 to the negative 3rd power? How do I make that positive, Nikki Kala?
Put a little bigger in the bottom.
Yeah, you know, if you want to do that, you want to sure I'll do that. Okay. What does it become? 1 over,
X.
this is a 3.
Oh,
3 to the positive 3rd power. And what is 3 to the 3rd power, by the way? 3 times 3 times 3, Hannah Nuzzo, is?
27.
Correct. So my answer really simplified for this one is 1 over 27. Now this one, here, the negative exponent's on the bottom. That's the vice versa part from the words there. So Lucas, what's going to happen?
You change the 5, negative 2 to the top and the 1 to the bottom.
Yeah, well, you don't have to, yeah. Well, 1 on the bottom of a fraction doesn't matter. This just becomes 5 to the 2nd power. You move it to the top. And what is 5 to the 2nd power? 25. So 1 over 5 to the negative 2 power is the same as 25. That's as tough as it gets for that part, anyway. Okay, now, when did you ask, wait, let me stop this.